Good afternoon and welcome to the extra session of this NPTEL course Transition Metal Organometallic Chemistry Principle to Application. So today, that is one day before our scheduled session, I am taking this as an extra session to complete this early, and tomorrow, like as usual session, we will discuss the overall summary of this course. So I will wait for few minutes if anybody joins. After that, we will start discussing the question answer series. So, if from starting from the last weeks, we are discussing the transition metal olefin complexes, and after discussing the olefin complexes, we move to another system, that is the diolefin complexes, and at the end of this course, we have seen and another important complex, that is the transition metal alkyne complex. So it is better to note that the transition metal alkene complexes are very much different from the transition metal carbene complexes. So don't confuse with transition metal carbene and transition metal alkyne complexes. So some alkynes are highly unstable. It easily undergo the cyclomerization reaction, or in presence of this catalyst, these alkynes undergo the cyclooligomerization reaction. So that is our main discussion topic in this week, that is the week 12 content, which is the last week content of this week. So we will start discussing after waiting for few minutes if anybody joins. Otherwise we will discuss the session from my side, and then we will upload the video as usual in the YouTube channel, and you can watch that later. So whoever is going to watch this in the YouTube, uh, tomorrow there is another class of summary session of this course, where I will completely discuss the course content without any problem. But and the main important thing will be, if you have any doubt, please make sure to ask this in the last interactive session, that is the tomorrow. And after that, there will be no such there will be no such interactive session. Still, if you have any doubt, you can mail me the following given address given in the assignments. I will try to solve your doubt as quickly as possible. We'll wait for a few minutes, then we'll start discussing the session through this problem solving approach. Okay, so still now nobody. Uh, okay, till now nobody has joined. So as the time is passing, so let's discuss today's question answer session. And if anybody join in between, we will try to interact them. And if they have any doubt, we will also clear that. Good afternoon. If you have any question, you can ask in the chat box also. If you have any question, you can ask in the chat box, or you can unmute yourself and also ask. Okay, okay, okay. Let's start the session. So welcome. Welcome again in the week 12, that is the last week of this course, as the problem solving session for transition metal organometallic chemistry principle to application. So today our first question is, which of the following best explains why conjugated diolefin from stronger complexes than isolated olefin? So first question is, which of the following best explains why conjugated diolefin from form stronger complexes than isolated olefin? So here we have the four option. So option A, they have higher MO energy, that means they have higher molecular energy, molecular orbital homo energy. Their delocalized pi MO allow extended metal ligand overlap. They can undergo strong sigma donation, and their pi orbital are less accessible. So here we have the four option. Option A is they have higher homo energy, their delocalization pi m allow extend, they undergo stronger sigma donation, and pi orbitals are less accessible. So we know that when the back bonding happens for diolefin transition metal diolefin complexes, metal donates its electron to the pi star orbital. So if and pi orbital for orbital electron are donated to the metal. So if the energy of the pi mo is lower down because of the extended conjugation, So this is the conjugated olefin, and if you have unconjugated olefin, I already explained this in the last day. So if you have, this is the unconjugated olefin. So unconjugated olefin, the molecular orbital of energy molecular orbital is higher. It is higher than conjugated olefin, because of the conjugation decrease the energy, for conjugation energy decreases. So this will have less energy, and this less amount of energy will facilitates to extend the overlap, extend extend the overlap with the metal. So because of the extended metal orbital, they are stronger complex. So that means they are stable. They are more stable than the non-conjugated olefin. So conjugated olefin form more stable complex compared to non-conjugated olefin, because of their delocalized MO allow the extended metal ligand overlap. So option B will be the right answer for this question. The next question is the upon coordination of 1,3-butadiene to a transition metal. Like the similar type, so when 1,3-butadiene is coordinated to the metal, 1,3-butadiene coordinated to the metal. So this is also coordination, this is coordination to the metal. Then it says that internal CC bond shortens, terminal CC bond lengthen, the pi AO population changes similarly to photoexcitation of butadiene. The pi AO population changes similarly to photoexcitation of butadiene. And overall CC bond alternation disappear completely. So what happened? So when we have these, so I am naming A, B, C, D. So bond distance of carbon carbon between A and B, between B and C, and between C and D. This is the CC bond distance. So CC bond, you can say that because of the sp2 sp2 hybridization nature, and here also sp2 hybridization nature, but because of the conjugation, here the double bond becomes almost similar. So but here, because of the conjugation, that double bond, that means A and B bond, is little bit lengthened. and B or C bond, because it is because of the why it is become length, then B or C bond, that is single bond is shortened. That means, and the last one is also double bond lengthen. So what happened here, let me explain. So what happened here, so we have this 1,3 butadiene. So now this is all carbon atom is sp2 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 and sp2 hybridized. Now upon coordination, because of conjugation, these bonds are become like this conjugation. So that means sp2 double bond is trying to getting sp3. Now because of that, this has a single bond character. So single bond, and this is a in between this sp2 and sp3. So in between this, so this single bond is little bit shortened to have the double bond character, whereas this double bond little bit increases to have the in between character of the single bond and double bond to satisfy this. To satisfy this, so what will happen, to single bond length, so the single bond length will increases, and the single bond length will decreases, and the double bond length will be increases when we have conjugated 1,3 butadiene system. So going back to the question, so what will happen, this internal CC bond, that means this bond will shorten. Yes, because it will be intermediate between the sp sp sp2 to sp3. So the single bond will be shortened, and the length of double bond will be increases. So option A is also correct. A terminal CC bond length, that is the CC double bond, and because of CC double bond character decreases, so this bond length also increases. It says that the pi MO population changes similarly to the photo excitation and of butadiene. So what will happen? So what does it mean by photo excitation? So for the pi electron, last day I also show that it has orbital like this, 1 1 1 1. So it has psi 1, psi 2, psi 3 and psi 4, 4 orbital. So it has electron 1 2 3 4. So 1 2 3 4. So what, it's not like this. So four molecular orbital is there. So psi 1, psi 1, psi 2, psi 3, psi 4. So 1, 2, 3, 4. But it has 2 electron here and 2 electron here. So what will happen? So when metal it is binding to the metal, metal can only also give the electron from the back donation. So that back donation electron will be appeared at here, which is similar to the photo excitation. That means 1, 2, 3, 4. Then in the photo excitation is one electron goes back to here because of the excitation. So here the similar case, that one electron coming from the outside to generate a excited state. Here one electron coming from the inside during the photo excitation to generate the excited, but both are generating the excited state, which is similar. So here the pi star population is changing because binding to the metal during the photo excitation of butadiene. So option C will also be the right answer. And option D, the overall CC bond alternation disappears completely. It says that the all CC bonds will be equal. That doesn't happen. There is a significant difference in the bond length, CC bond length in butadiene upon coordination to the metal. So this is not a correct answer. So option A, option B and option C is the correct answer for this compound. Question number 3 is, which type of orbital interaction is primarily responsible for stabilizing eta 4 diolefin complexes? Option number A, sigma donation only. Option number B, pi back donation. And option number C, combined sigma donation and pi back donation synergy and ionic interaction. The question says that which type of orbital interaction is primarily responsible for stabilizing the eta 4 diolefin complex.
So one possibility sigma donation can take place. I would say like option C, combined of sigma donation pi by donation.
Hmm. So, as per we have discussed that here for the sigma on transition metal complexes, both are happens like the transition metal carbonyl complexes, but here the pi donation is little bit less favorable because here all are carbon atom, so that the pi star is little bit higher energy, whereas for the carbonyl we have one heteroatom of oxygen and which is also highly electronegative, so it brings down the molecular orbital energy. So that's why energy mismatching is for the olefins. So here the pi donation and sigma donation similarly happen like the metal carbonyls. So here option C is right answer. Next quiz, which experiment techniques best distinguished which experiment technique best distinguished between the acetylenic eta 2 and metallocyclopropane sigma pi from? Which experiment technique best distinguish between acetylenic eta 2 or it is macrocyclic form? That means if we have C triple bond C and here let's say R, so that means this is eta 2 ether 2 mode of bonding, and for a metal or cyclopropane it will be like this. This is the two different thing.
XRD.
Okay, XRD, X-ray diffraction. Then this is the only option.
Just a minute, sir. Then I think it should be UV spectroscopy. UV spectroscopy.
And then
I guess these two should be the answer.
okay. So what is the range of UV visible spectroscopy? What is the range of UV visible spectroscopy in our spectrum?
190 to 800.
190,
Yes, sir.
190.
That is 190 to 800. That is for UV, and then the visible region is from 400 to 800 nanometer.
So that means 190 almost 200 to 800.
Yes, sir.
So that is the UV range. And what
Yes,
is the
sir.
IR range?
IR range will be like 1400 to 12,800 to 10 centimeter inverse.
What?
12,800 to 10 centimeter inverse.
So IR range is generally 4000 centimeter inverse to 600 centimeter inverse. That is your IR range, and this is the UV visible range. It is nanometer.
Yes, sir. Nanometer range. UV is for nanometer, IR is for centimeter inverse.
Because IR we measure in a wave number form, but that doesn't matter because both are proportional to the energy. 400
Yes,
means
sir.
more energy, 600 means less energy. There is, so here for the IR relation, IR spectrum, we say nu bar. Nu bar is also directly proportional to E, and here lambda wavelength, that is also directly proportional to E.
Energy.
Okay. So triple bond generally appears in the
No,
IR.
sir. Energy is inversely proportional to lambda, right?
Huh?
Energy is inversely proportional to lambda.
Huh? E equals to H nu. Sorry,
It's
is
E is equal
proportional
to
to,
HC by lambda.
is proportional to nu, not lambda.
Okay, okay.
1 by lambda equal to
Nu bar.
nu bar. That is proportional. So nu bar is proportional to
Proportional to
E.
energy. That is proportional to energy.
Yes. So that is proportional to nu. E equals to H nu. So here it is. Okay. So in triple
Yes.
bond appears in the IR region. Also, this double bond stretching appears in the IR region. So when it changes from triple bond to double bond, we can easily detect by the IR spectroscopy. So IR spectroscopy is one of the answer. Another is the NMR spectroscopy. So what will happen? So this will be a sp3 character carbon, and this will be a sp2 character carbon. So for that reason the NMR will easily distinguish whether it is sp2 or it is sp3.
No, sir, it should be SP, right?
It is sp and sp2. It should
Yes,
be
sir.
sp and sp2. Okay.
Yeah.
So triple bond is sp and this will be sp2. So NMR can easily distinguish between the sp2 and sp carbon atom. So NMR spectroscopy you can also determine. Another is obviously X-ray. X-ray you can see a cyclopropane type ring and whether is a purely coordinate interaction. Okay.
Yeah.
So and UV region is far lower, is for far higher energy. That much higher energy is not required to distinguish this. What is the energy range? There is a range, na? So how which is highest energy? Highest energy is
Visible range.
no
Ultraviolet.
ultraviolet. Before that,
Before that, it should be visible range.
no. See, let's say
Mm.
if I
No.
draw a arrow. Electromagnetic region. The highest energy will be gamma ray,
Yes, sir. Highest is gamma. Yeah.
then X-ray,
X-rays here.
then UV, then
Yes, sir.
visible,
Then visible range.
then
Then IR.
IR, then
Okay.
microwave,
Microwaves.
then radio frequency.
Radio waves. That's all.
This is the from highest energy to lowest energy. Okay, so here this IR energy and NMR, IR energy and NMR is enough, and obviously the X-ray determine. UV you can determine, but that change will not that much efficient to detect in UV visible. Best is IR, NMR and X-ray. Next question is compare the free acetylene CC triple bond 120 pm picometer bond length a metallocyclopropane type complex typically shows the CC distance of. Already discussed this question, is question number 1. So compared to free acetylene, the metallocyclopropane type complex typically shows CC distance of. What is metallocyclopropane? This is M.
Eminent remember ring.
The
Ah,
thin
yes.
type of ring like this. 3-member ring. So this CC, what will happen to CC distance? So this was previously C triple bond C R R. So when it react with metal, it become like this. So if let's say this is 120 pm as for example, so what will be this? Again, this is the hybridization. Okay, so when this metallocyclopropane bind with the metal, what will happen? This alkyne bind with the metal, what will happen? It also receive the back donated electron. Also the hybridization decreased from sp to from sp to sp2.
SP2 is.
This was sp, so this is becoming sp2. So that will definitely
Decrease the bond order.
increase the bond length.
Increase the
Increase the
bond
bond
length.
order matlab increase the bond length.
Yes, sir. Ah, okay, yeah.
Increase the
Bond length. So which means stretching frequency decreases.
stretching frequency decreases, bond length increases. So it will increase
Decreases.
to 120. It will be close to in the range of 130 to 135 picometer. So in this question you can see that. So if you understand this, what will happen compared to free acetylene? So 100 picometer is never possible because bond length will not further decrease, because acetylene C triple bond C is the shortest bond length. It cannot be decreased. That C 4 bond C is not possible. It is
No,
not
sir.
possible. Okay, this is the shortest bond length. So whatever the bond length will be, that should be more than this. Again, how much more than, that is the question. So 120 is also not possible, and obviously it will not increase 30 picometer. It will be like 10 to 15 picometer increase there will be observed. Okay.
But sir, one thing I didn't understand, like you told the stretching frequency decreases, right? But then how it is like increasing 130 to 135? This is carbon-carbon distance, right? You were saying. This is you mean saying carbon-carbon bond length. Okay.
Carbon
Okay, sir.
carbon
Okay.
distance, carbon carbon bond length the same.
Yeah, yeah, okay, got it. I thought it was stretching frequency. I got confused.
Stretching frequency will decrease when bond length increase.
Increases, yeah. Bond order also decreases.
Reverse. Bond order also decrease,
Yes, sir.
because
So
bond
stretching
length
frequency
to bond
decreases.
order is in, you are inversely proportional.
Yes, sir, yeah. Inversely proportion to bond length,
Hmm. Got it correctly?
but directly proportion to stretching frequency.
Hmm.
Yeah.
Okay.
Yeah, got it. Got it.
Next question is the, that is also important question. The electron withdrawing substituents on alkyne ligand like Cl, C triple bond, CCl increase pi back donation, stability of the metal complexes, tendency towards cyclometallocyclopropane structure, explosiveness of the complex. So electron withdrawing substituent on alkyne ligands. As for example,
So
this.
if that electron withdrawing substance is there, this means back direction decreases,
What will be
right?
the answer? A, B, C, D.
I think B.
Okay. So
Yes, so generally I'm asking like whenever electron withdrawing substance is present on the alkyne carbon, which means the back donation tendency decreases, right?
we have our pi orbital. Let's say this is sigma, this is pi, this is pi star, and this is sigma star. So this is pi orbital. Okay. So what will happen when there is a electron negative group? Electron negative group will withdraw the electron from these two carbon. It will withdraw electron. Okay.
Yeah, yeah, withdraw.
Let's say C triple bond C Cl Cl, and this is donated to the metal.
Metal.
So this chloride will withdraw electron. So for that reason, what will happen? The metal electron will push the electron in the pi star orbital, because of this chlorine is withdrawing the electron. Got it,
Yeah, yeah.
right?
This
Because of
acetylene becomes electron deficient, so
uh,
metal being electron rich, like pushes electron to the pi star
then
orbital.
metal will take pushing the electron pi back donation because of the chlorine with the electron withdrawing effect. So this is
Yeah.
giving more double bonded character, and after some time it convert to metallocyclopropane structure. So this will increase the pi back donation because chlorine is withdrawing the electron and this is withdrawing the electron from this bond become electron deficient, so pi star is stabilizing and this pi star will accept the electron from the metal as pi back donation. Pi back donation. So this pi back donation, what is happened? Stability of the metal alkyne complex, obviously, because alkyne and metal forming a multiple bond, more than one bond to stable, so that why stability also increases. And then tendency towards the metallocyclopropane structure. Yes, why? Because the back donation is so much that this bonding is breaking and that pi star is saturated with the electron and it converts to the metallocyclopropane structure. So option C is also correct. And the explosiveness of the complex, yes, so these type of complexes having highly explosive explosive, so upon binding to the metal the explosiveness also decreases. So here sets increase, obviously explosiveness decreases because of the binding to the metal. So here it is the non-correct answer. Option A, option B, option C is the correct answer. Okay.
Yeah, one more doubt, sir. Like I already asked you many times, sir. Like when chlorine is attached to acetylene group, so which means what happens is pi by donation of acetylene decreases, but sigma donation increases. Am I right or wrong? That's what I'm asking.
Chlorine is withdrawing the electron, so
Yeah.
pi donation will also decrease, but here we
Yes,
are
pi
talking,
donation increases, but sigma donation increases.
because here we are considering the increase of not the CC pi bond or CC sigma bond. Here we are talking
Yeah.
about the bonding between the metal and this CC carbon.
Yeah.
Okay.
Pi donation back donation happens because metal already has electrons, so electron rich, so which means it donates back the electrons to pi star orbital. That's the reason it forms a metallocyclopropane.
Huh. So when generally when we talking about the carbonyl compound, we talking too
Yeah.
much about the metal carbonyl, not in the metal carbonyl bond, but we talk about the bond strength of carbon and oxygen. Okay.
Yeah.
So when you have the metal C triple bond O, when you have this, we are always considering the bonding of this. So depending upon, because this has a because the bonding of metal to carbon has a direct effect on this bonding of metal and carbon and oxygen, which can be easily measurable. Okay,
Okay, sir.
but for this case, this alkyne clays, we are talking about the not the CC internal CC bond, we are talking about the metal to carbon bond. What will happen to metal to carbon bond? Obviously metal carbon back donation increases, stability will increases because multiple bond formation is happening between the metal and carbon. Then tendency to the metallocyclopropane structure, because the two electron, it will be completely equivalent to the alkyne and it will be a metallocyclopropane structure, and the compound is highly explosive as it is binding to the metal, so its explosiveness also decreases, it will not increase. Okay, so this is option D is not correct according to this question. Next is the cyclo-oligomerization.
Also, one more thing, why can explosive can't come into picture?
This is
That is my main.
no. This is the nature of this acetylene compound.
Okay,
This is some acetylene compound are highly explosives.
okay, sir. Like in this case, like
We have
this
react in
explosive
water.
is actually explosive, but when it makes a donation with like a metal atom, then it becomes less explosive.
Yes, explosiveness
Okay,
decreases
okay, when it coordinates with metal
significantly,
atom.
and you can because of the coordination to the
Yeah,
metal.
yeah, okay, got the point.
That is another important point of preparing transition metal alkyne complexes. We can use the alkyne, and it is not even explosive anymore. The next question is the cyclo-oligomerization of alkyne using CO4 catalyst typically yields. So what will happen if you use a cyclo oligomerization of alkyne using COCO4? So what will generate? You will generate an alkene, you will generate an alkylidine, you can generate aromatic ring, you can generate a cyclopropane ring. In this it says cyclo oligomerization. Cyclo oligomerization. So cyclo oligomerization. Let's say we have three acetylene moiety. So it
Yes,
will
sir.
give you a
Benzene. Yeah,
benzene
this
ring.
aromatic ring.
This is called aromatic ring. So aromatic ring will be the right answer for this
Yes.
question.
Okay. Cyclo-oligomerization. Sir, one more thing. Cyclo-oligomerization means like three alkynes, right?
Hmm.
Combined to forgive an
If you
aromatic
have
ring. Okay.
instead of this, if you have one is, let's say we will use that. Say they use three alkyne. Instead of this, you use one nitrile. Nitrile, the symbol is, let's say, phenyl N
C triple one.
C triple 110.
Yes, sir.
Then nitrile. So then you will end up with a nitrogen here.
Nitrogen here. Then phenyl on the carbon.
uh, that will generate a pyridine derivative.
Sir,
Huh?
could you repeat what you said? It will generate what?
Pyridine derivative.
Pyridine. Ah, yes, sir. Yeah, yeah. That is also aromatic.
That is also aromatic. If you have one nitrogen, so one nitrogen will one carbon will replace by one nitrogen, so that will generate a pyridine moiety.
Yes,
That
sir.
we will discuss last. Question number 8. Which statements about the transition metal alkyne complexes are true? Option A. They can stabilize highly strained highly strained cyclic alkyne like cyclohexane. Pi back donation relieves ring strain by bending the alkyne. Complexation increases the C bond length. All alkyne complexes are linear. What will be the correct statement?
Sir, number C can be one answer. Number B also can be an answer. Hello?
Okay, so B and C are the two option, and any another option one correct?
Still checking, sir. This is a linear stimulus solution cyclic alkanes like cyclohexane. I think B and C are the answers, sir.
Okay, so
You can let me know your
let's go
opinion.
back to the last question.
Yes,
So
sir.
here we have seen that any alkyne which are explosive that can stabilized upon binding to the metal. That means when that alkyne binds to the metal, it gives the stability of that system. So similarly, the cyclohexane moiety, cyclohexane, cyclohexane, this is this.
Yes, sir. Oh, okay, okay.
Okay. So here what should be the bond angle? 180 degree.
90 degree, yes, sir. It is linear.
And here actual bond angle is very much shorter than this. Okay.
Yes, sir.
So that's why it is highly unstable. Unstable. So when it binds with the metal, the similar thing happen, already I have explained. Then only it can, the stability increases very much. So the alkyne, transition metal alkyne can also complexes the strain ring structures.
Yes, sir. Which means they can form metadocyclopropane
Huh. They
by
can
stabilizing it.
they can stabilize the strain cyclopropane or cyclohexane ring structure.
Yes, sir.
So this is also correct. So it is in the
Yes.
category of MSQ. So next question is also an important question. So it says that the sodium tetrachloroplatinate when react to it T-butyl to C2, that means C triple bond C T-butyl T-butyl. When it reacts with this in presence of ethanol and amine medium, what it will generate?
Option B, sir.
So option B will be ultimate. What is the oxidation state of platinum?
Initially, oxidation state is +4.
And here also,
Here also it is +4, sir.
ah, so obviously, and there is no role of RNH2. Is there any role in this reaction?
No, sir. I don't think there is any role.
So this option cannot be correct. So any cyclopropane formation will be possible when at the end, when this Eta 2 olefin structure, eta 2 alkyne structure is not possible. Eta 2 bonding mode. So eta 2 alkyne structure is not possible. So here this this chloride is there 4. So 4 chloride will replace by one of 2 chloride will one. So it will be PT palladium, sorry, palladium, PD, PT, and this will decrease the state, and it will be palladium, platinum 2 and RNH2, and this will be in trans fashion because this is a eta 2 mode of coordination. So D option number will be the right answer. If you hit this or something you do, then only it will change to the metallocyclic form, because this is a platinum and platinum is almost highly stable molecule.
No, sir. Whenever when this PT cells are reacts with TBU2, C2 in presence of ETH, then the B product will be formed. But upon reaction to RNS2, what happens is it converts to eta2 form, right? Then it
Yes,
becomes RNH2 or converts to PT.
yes.
Okay. Oxidation rate is not sure. Okay, sir. But oxidation rate is same in D as well.
Hmm.
Plus 2.
Okay.
Yeah.
The next is, which is not a coordination mode of alkyne ligand. This is directly from the
Option
slide.
D.
We will see it in the slide. Okay. I
Yes,
am
sir.
not
I think
doing.
D should be one option.
So you are saying D, so I am marking D as a round. We will
Okay.
discuss this at the end. Question number 11 again. Among the following, the more stable alkyne is. So see carefully all the alkyne. So first one is benzene. What is the structure? This,
Benzene ring outside of the benzene is a triple bond.
this.
Yeah.
Then this Cl, C, triple bond,
Triple bonds.
CCl, CCl. So we have
Yeah.
already seen that it is explosive.
Explosive. Yeah.
Explosive. So obviously this is not stable. We are already cross mark here. And cyclohexane. This is cyclohexane. Another is PHCCPH. PH means PH C triple one C PH. So between benzene, cyclohexane, and this, which one will be more stable? So this one is explosive. We are already cutting it out at the instant. So which one more stable?
Benzene.
So there is two things that we already discussed. This cyclohexane is not stable because of
Benzene.
high ring strain, because this is
Yeah.
sp2 sp, and here other
Yeah. SP
sp3,
converts to
so
SP2.
it is highly strained angle. So this is
Yeah.
highly unstable. So benzene, you cannot isolate it. It is forming in the reaction medium. This is also
Yes.
highly unstable. And the remaining one is this PHC
PH
triple
one
bond
C
C.
PH.
Like instead of PH, last reaction we see the T-butyl one.
Yes, sir.
That is also more stable. So here all are three unstable. Stable one is option number B, PHC triple
B.
bond C PH.
So benzene is also strained molecule, you're saying.
Benzene is also
Similar
strained,
to cyclohexane.
like the similar, and it also form in the reaction medium. It's very difficult, not possible to isolate.
Okay.
Okay? Option B will be the right answer. Next, that CP2, TiCO2, PHC, and we another thing you notice, that whatever the stable alkyne, we only react with that, not with benzene, not with cyclohexane. The CCl4 react with this to gain the stability. Cyclohexane react with the metal to gain the stability. So here your alkyne is already stable, so there is no issue with the stability. So you are reacting it in a hapten in vacuum 25 degrees centigrade 3 hours.
Yes, so CP2 TiCl2, that is titanium is bonded with two carbonyls and then two cyclopentadienes. So what happens is when this alkyne binds with this titanium complex, so what happens is one of the carbonyl leaves such that it forms a eta 2 type linkage with the titanium.
Hmm. And
The
after
one with
that
the one which
it
is
will
option B.
combine to a cyclopropane ring. Okay.
Okay.
It will end up with the formation of cyclopropane ring. So one of the carbonyl molecule will leave and it will be a cyclopropane ring. So option number C will be the right answer. The
But
next
sir, like when it forms, okay, the CO will be still standing there. Like
one
when
will
the
be
eta
there,
2 converts to
one
minus
CO
eta
will be
2.
there. There is
Okay.
two CO, so one will be there.
Yes, sir. Okay. That CO won't be leaving. It will be as such.
Huh.
Okay.
Next,
Yeah,
what will be the product?
okay. Give me a moment, sir. Sir, sodium amalgam is is a reducing, right?
Yes.
So which means that the two bromines will be converted to a cyclobenzene,
Huh.
cyclohexane.
Huh.
Then I think option A might be the option.
Huh. So what will
Metanoplatin.
happen here? You have the sodium amalgam that will
Yeah.
do the formation of benzene, and it will
No, sir,
also
cyclohexane.
cyclohexane
Yeah.
intermediate, and it will also stabilize by this. Okay.
One triphenyl phosphine will be removed such that it forms a metalloplatinate.
Yes.
Oh.
Got it.
Yes, sir. Option A is the right answer then.
Yeah. Next is, and also you can see that here sodium amalgam act as a reducing agent.
Yeah.
Next is, I think this is the last. Next is, it should be 14. Question number 14. Bornemann reaction is the last reaction which we are going to discuss in the session. In this session means in this course content, in week 12 content. It is a named reaction. So Bornemann reaction is cobalt catalyzed cycle addition of alkyne giving the homocyclic system, The Lewis acid mediated cyclization of divinyl ketone gives the cyclopentenones. Option C, the cycloaddition of a conjugated diene and dienophile gives the cyclohexane. Option D, the cobalt catalyzed cycloaddition of alkynes and nitriles gives the pyridine. What will be the answer? Is this cobalt catalyzed to give the homocyclic product? Lewis acid mediated cyclization of divinyl ketone and the cyclization of conjugated diene and dienophile, and cobalt catalyzed cyclization of alkyne and nitrile to give the pyridine derivatives.
That one I'm not sure, sir.
So as I told that I have already explained this example. Here we are discussing the cyclo-oligomerization reaction. So in cyclo-oligomerization reaction, we seen that formation of benzene when we have three symmetrical acetylene, that will end up with benzene. So if you remove one of the benzene with this, what will happen? It will convert to the pyridine. So this is catalyzed by this cobalt complex. So it is cobalt catalyzed cyclization of alkynes and nitriles gives the
Okay.
pyridine.
Okay, okay, sir.
Okay.
That is the name reaction. Okay,
Yes,
sir.
it
I
is
didn't know that.
kind of name reaction at the end.
Yeah.
Okay. I think all of the question I have answered.
Also, one more question. That is, you mentioned about a question which is like which is wrong about the metal donation, metal alkyne donation.
Huh.
I said is option D.
Huh. We'll go to that. Here. Can you see the screen?
Okay. Yes, sir. You can see the screen. Yeah.
Which one is the correct answer?
Option B is the correct answer.
So last, this is I told in the first session also for the olefin system, so that olefin size is too small. It cannot donate more than 2 metal center. And here
Yes.
it is simultaneously binding to a 4 metal center, which is quite impossible.
Yes, sir.
Okay, but it can
Yeah.
bind with the 2 metal center, like carbonyl. Carbonyl simultaneously can form a terminal bond as well as a bridging bond, because carbon should bind with the 2 metal center. Here also this can only bind to the 2 metal center, and above 2, 3, 4, 5 metal center is not possible for binding for this C triple bond C. Also you can see that the nucleophilicity or like binding is more stronger for the carbonyl rather than the olefins.
Yeah. Yes, sir.
Okay.
Yes, sir. Yeah.
Okay, so this is the reaction. You can see that whether the bond angle is important. So bond angle is 165 degree, whether ideal angle for the sp carbon atom it should be 180 degree. Next is, now we have seen this question also. When this leaves, one CO molecule leaves and two of the molecules undergo the attack of cyclopropane structure. Cyclopropane.
Yes, sir. Yeah.
Cyclopropane structure. Okay.
Yes, sir.
And next, this one. This is undergo also cyclopropane structure. And this is the characterization. So you can see that you can characterize by the NMR spectroscopy, because NMR you have a different chemical sheet value for sp2 and sp3, sorry, sp2 and sp carbon. We have a different chemical IR stretching frequency for the olefin and alkyne, and obviously from the X-ray you can distinguish between the binding mode of olefin and alkyne. After
Yes,
that,
sir.
this you can see option A, you told it is correct. Here platinum is used, sodium amalgam is used as a reduction agent which will undergo this kind of reaction. And this is also cyclohexane formation. Cyclohexane is highly unstable, but when binding to the metal it gives the stability. And this is the benzene molecule. So not only one benzene, so it has two acyl moiety in a single benzene ring, which is highly unstable, but upon coordinating to this nickel it can be stabilized. This reaction is another very important reaction which I did not include here. You can see that when you use a BH4 minus. So what is BH4? This is very tricky.
Tetraborohydride.
Huh. What is the role of it?
It's a reducing agent.
Yes, because
Yes, sir.
it they has not write is that if you write NaBH4, you easily understand it is sodium borohydride is a reducing agent. But they have
Yes, sir.
written is a trick in the question.
Yes, sir.
Okay, it is written at a BH4 minus, so borohydride anion. It may be potassium, it may be sodium. Sodium is readily available, so sodium borohydride do the reduction.
Yes, sir. Reducing agent. Yeah.
So do the reduction of alkyne, and eta 2 alkyne is converted to now eta 3 allyl
Alpine.
system. So
Analysis.
system is totally changes. Whereas it is eta 2 alkyne. After reducing this, it is localizing in the 3 bond and it become eta 3 allyl.
Yes, sir.
Hmm? This is also very another important example. So how this changes? Eta 2 to eta 3. This is the mechanism for this. You can go through it if you are interested. And lastly, another example is here. You can see now we have just see eta 2 alkyne complex converts to eta 3 alkyl complex. Now in this example you see that the versatile transition metal coordinated alkyne ligand can be converted to a variety of organometallic compound. That means alkyne convert to alkyl. Now here you have alkyne, eta 2 alkyne, the same thing. Upon reduction it will go to this, and when heating at 80 degree this hydrogen is leaving and it is becoming a carbene complex. So there carb alkyne complexes complex convert to alkyne complex converted to alkyl complexes, and here alkyne complex convert to carbene complexes. So this is very interesting and it can be asked in the exam also, this transformation.
Okay, sir.
And this is some of the example where the oligomerization or tetramerization reaction, tetra and trimerization reaction happen to give the cyclobutane or cyclooctane or benzene type of system. So lastly we move to the another system whatever discussed, that this last lecture. Here is this one we already seen that when alkyl is there it undergo cyclization reaction to gives the aromatic ring. So here it is concerted aromatic alkene. So two alkene part is the terminal alkyne part, one is the free alkyne part. So these two undergo the cyclization, cobalt catalyst cyclization, so it will give the aromatic ring. And
Yeah, okay.
here, if here you can see, here is
Hmm.
said you have two molecule of acetylene and you are reacting with nitriles, not isonitrile, only nitrile. So you are
Yes,
getting
sir.
the
Yeah.
in presence of
That is,
cobalt
if one
catalyst.
alkane is replaced with one nitrile, then it
No,
forms a pyridine type derivative.
pyridine, one of the pyridine derivative.
Yeah.
So this is reaction is called by Bone-Mann cyclization
One
reaction.
one has acceleration reaction. Okay, sir.
This reaction mechanism is also important. So first, what is happening? See carefully. CP, that is cyclopentadienyl, is there. Cobalt is there, and ligand 2 is there. So ligand 2 can be ethylene, can be cyclooctadiene, something. But this ligand is dissociated in the mechanistic cycle. That means this L ligand is very labile and it is not entering to the catalytic cycle again. That means this is the active species for this compound. So now the acetylene inserted into this, and after that the another acetylene molecule inserted into this to get these acetylene complexes. Now one of the isonitrile inserted to this, and after forming a metallus cyclopropane type structure, it have an isonitrile which another goes cyclization to generate the active catalyst pair and the derivative of pyridine. Okay.
Yes, sir.
Okay. So this reaction mechanism is also very important reaction mechanism. Here also you can see when instead of that by controlling the temperature and pressure, nickel cyanide as a catalyst in presence of calcium carbide and THF in 80 to 120 degree centigrade temperature and 15 bar of acetylene pressure, you will get a cyclo octatetraene. This is the industrial procedure for developing or development or synthesizing the cyclooctatetraene. A similar reaction of cyclization. Another is this. When, but when instead of, so we have seen that when we have only acetylene moiety, it will give the benzene ring. When we have nitrile, it will give the pyridine ring. And in the medium, if you have the carbonyl, we are getting a cyclic ketone. See, the iron pentacarbonyl, if you heat it, it will relieve the CO molecule, CO gas. Now, upon reacting with it, we get a cyclic ketone bounded to the metal. So similarly, this compound, ferroyl ring, this is very important compound. So when iron pentacarbonyl reacts with acetylene at a certain temperature and pressure, it form a ferroyl ring type complex. That means one of the cyclopentane ring is a part of carbonyl, and cyclopentane ring also donated to the metal center. So this is a thing, and another end the alkyne as 4 electron donor. So this is the alkyne when it can donate the 4 electron. This is very interesting example. And lastly, the alkyne, this question is also a very important question, so try to understand this question. So when we have this kind of double bond, so we can have seen that 3 olefin combine to give benzene, and now this has a double bond, so this double bond will also react as a olefin. So this olefin, so two of the molecule will combine, as we told that metal carbonyl, when use the metal carbonyl, upon heating, if we heat this reaction, upon heating it will generate a, it will generate a,
1 second.
it will generate
It will generate a, like a ring, 5-member ring.
it will generate carbonyl it will generate
Or
carbonyl.
no, sir, which one? Using Paulson Khand reaction.
Huh.
Okay. Ah, yes, okay. Yeah, okay. Upon heating, then it will generate, yeah, that is ketone.
The carbonyl will come from this CO2 CO8. So if you
Okay.
have molybdenum hexacarbonyl, if you have tungsten hexacarbonyl, molybdenum hexacarbonyl, MoCO6,
Yeah, 6.
tungsten CO6, this is all upon heating will generate CO. So this CO group is coming from here, and another one is this alkyne. So this olefin, alkyne and CO is coupled together to give a ketone. So if you naming this, so this will be alpha, this will be beta. So alpha beta unsaturated ketone, or it is also cyclic ketone is generated in this reaction. So this is another very important reaction. Okay. So I think this is all. The Bone-Man reaction also I have explained. Any other doubt or question? Here also you can see that we have iron pentacarbonyl. So iron pentacarbonyl also on heating generates the CO molecule. That means one CO will be there. For simple pH, this CO is not forming, only cyclobutane derivative is forming, but in presence of other like methyl, ethyl, it is forming like a carbonyl unsaturated, alpha beta unsaturated carbonyl compounds.
Okay,
Any
sir.
clear? Any other
Yes, sir.
doubt?
Not now, sir. Yeah, it's no doubt, no doubt, sir.
Okay, so tomorrow we will have another session. So you will go through all the slides and all the questions. Okay,
Okay, sir.
all the slides and all the question.
Question. Okay, sir. Like same time tomorrow?
Huh. Like we have the session of Sunday, na, every Sunday. Today is Saturday.
Yes, sir.
So tomorrow
Yeah.
Sunday will be the last session for this. So tomorrow Sunday we will discuss first.
But sir, can we also keep further sessions? Like if in case I have some doubt or something.
If you can, if you have doubt, you can ask till exam. You can ask me for my portion in that email. I have shared my email in the
Yes,
first
sir. Yeah.
email. You can email, and if you it is a technical doubt directly from the slide of the lecture video or the portal which is uploaded in the portal,
Yeah.
that you can directly ask in the discussion forum. And if you have any doubt from my question part or my video part, that only you can email me. Okay, but
Okay.
any kind of portal doubt, exam related doubt, better to ask in the discussion forum or in the NPTEL team.
Yes, sir. Sir, one more thing. Our exam is on like on 26th of October, right?
Huh.
Yes, sir. But I don't know. I got an email by saying that examination dates are 11, 12, 13, and 14. That is for 648 courses under SWAYAM 2025 July semester program.
So you got a problem with your admit card, that is solved?
No, sir. It's I don't know. I didn't get any reply from them.
Oh, okay. So they will what is this? They will resolve it. I think you will
And
get
sir,
a
one more thing. I just got a mail that tomorrow I think sir will be coming live to answer some questions.
huh. Though there is an
Professor.
announcement I can show you. It is not loading. Announcement.
Around 10 a.m. tomorrow. Oh, sorry, 13th, I think. Okay, sir. Okay.
A. The
Uh,
exam date for this course is October 26, 2025.
okay, sir.
Okay.
Yes, sir. So I have to request for the hall ticket to them, right? That is to NPTEL that, portal.
Huh.
Okay, sir.
Hmm. So here tomorrow will also be a session like same time which I will conduct, and here you can see one announcement is there. Can you see it?
Yes, sir.
So here you can
Yeah, that is
see,
Professor Ghosh will go live with
huh.
us.
So he will be live through YouTube, not through
Okay.
Zoom. So here is the
Okay,
YouTube
sir.
link is there, and you can put your doubt. So here suggestion is, whatever you have doubt regarding your portal problem, exam
Yes,
problem,
sir.
that only you can discuss with him. Don't discuss anything which I have shared the content, because he
Okay, sir.
has no idea what I have shared. And if you have doubt on my question, you can directly ask tomorrow me, and you can email me
Okay, so I don't have to ask doubts to Professor Ghosh.
regarding my content.
Like earlier contents.
No, that is, you should only ask the doubt which is there in this portal.
Yes, sir. That's what.
Huh. You cannot say that I have seen a live session on Saturday, on Sunday, where this question was discussed. But doesn't. This part is completely my responsibility. If I say I am something wrong, that is also my responsibility. Okay?
Yes, sir. Okay, sir. I won't tell. I won't tell
Huh.
about the session.
Okay.
I'll just
So,
ask. Maybe I might just post some doubt from any topic which has been
huh.
covered like so far.
So you, and when referring to a doubt, let's say it is week 1. I'm no sorry, week 12. So
Yes, sir.
this is week 56. Okay, lecture
Yes.
number 56. So I'm just giving an example. So this is lecture number 56. So if you want to ask a doubt, so just go to that portion when you have doubt. Let's say this is minute 4.58. Okay,
Okay.
so
Yes, sir.
you just mention that in that lecture number 56, minute 4.58, then write your question.
Yes, sir.
Or
Yes,
when
sir.
writing in the chat box, that also you write. So lecture number 56, minute 4.58, lecture number 57, minute this is, I have this doubt.
Yes, sir.
That will be very easy for him to explain. Otherwise, if you randomly ask some question from any of the lecture, that may be confusing.
Okay, sir.
Okay, and there is some
Yes.
portal assignment also. You can ask question from the portal assignment, because the assignment are now already solved, solution is already given.
Yes, sir.
So
Actually, sir, I have some doubts, sir. Like, I have got majority of the answers is correct, but there is one answer which I didn't got correct. Could you please scroll down?
this
This
week
week
12,
11 assignment.
huh?
Yes, sir. Could you please scroll down? This let you know.
Which
Hold
one,
on.
which number?
Go down, sir. Yes, sir. I'll let you know, sir. Go down. Yes, sir. Question number 8.
Huh?
So because see here in this case Ru is there and then two double bonds are there. So which means two double bonds are forming like a cyclobutane team. So it should be metathesis reaction. I am out, but it is showing reductive elimination. Hello?
Huh, huh. So this is, it says
Yes, sir.
that this reductive elimination. Okay, that's fine. So you
But sir,
just,
how it is reductive elimination? I thought it is metathesis reaction. I marked metathesis. That's the reason.
okay, let him explain this. Okay, so when you, my suggestion is, when you ask any question from this portal, mention
Yes,
that,
sir.
mention where the question is.
Assignment 11. Yeah, okay. Question number
Assignment 11,
5.
question number 11, and then question number 8, I think.
Yeah,
Huh?
question number 8. Yeah.
Question number
Right.
8, then write your question.
Okay, sir.
Okay, so if you have any doubt from the video lectures, like week 12, week 11, then you write video
Week
lecture
11,
number,
lecture 52.
lecture 52,
Minute.
53, and this minute of that lecture,
Yes, sir.
4.52 minute, I have this doubt, this question doubt. That will be
Yes, sir.
easier for answering. Okay, and here is a link, na? So this is a link. I think this is a Google form or what?
Google Forms link.
Huh. This is a Google form. You write your name, mobile number, email ID, choose your profession,
Yes,
and
sir.
then after that you write your answer question here and write it. Huh?
Yes, sir.
Okay.
Yes, sir. Got it.
And again, I am saying, when writing any question, at the first you mention the time and lecture number.
Yes, sir.
So they are from lecture 0 to lecture 12. So total 60 lecture, and every assignment. If you doubt in any other assignment, that also you can write assignment number this. No, so it says week 11 assignment. So week 11 assignment, I have put doubt on question number 8. Then you write your doubt.
Yes, sir.
Clear? Okay. And I have also uploaded that thing that slides in my part in that drive. You are also getting that, na?
Yes, sir.
Here I think, here, when you have this survey, you have this survey,
Sir.
and then
Yes,
here
sir.
is a recording sheet. If you open this recording sheet, and here here it is, that presentation folder link. So or
Yeah.
whatever I have presented, question answer I have discussed, so all questions are uploaded in this Google Drive link.
Yes, sir.
Okay. So this is the Google Drive link. So here in all the link you have that email address and all the questions, and here is the all the YouTube links whatever I have discussed with you. So if you have any doubt to this YouTube link and this presentation folder, you should directly ask me here. Okay. Week 11 is already uploaded, so week 12 I will upload today, and tomorrow there will be no slide because I will just scroll down that book which is already in the portal with these books, English book, and you will just go through this book one time, overall 1.5 hour or 1 hour 40 minutes, this book, and then we will discuss the some of the important reactions, some of the important topic, uh, and and still if you have remaining some doubt, then you can ask me. Okay, see you tomorrow same time.
Okay, sir.
And as per I told that it is better to ask in the live, you just type all your question here.
Yes, sir.
Huh? So you type
Yeah.
all your question in a word pad, copy it and paste it there. Then
Okay, sir.
you can all, then when he will go on live on YouTube serially, he will answer all the question.
Yes, sir.
Okay. Okay, thank you, see you tomorrow again.
Thank you, sir. Thank you very much.